Welcome to MechTech 40. So, in previous classes, we have studied various numerical methods, and rest of the portions we'll study today. So, if while evaluating the numerical integration by using trapezoidal rule and by evaluating with the normal integration rule, the values will match in case of polynomial of degree 1. That means trapezoidal rule will give exact value for polynomial of degree 1, so error will be 0. In case of Simpson's one third rule, the it will give the exact value for polynomial of degree 2. For 3 by 8 rule, it will give for polynomial of degree 3. But the standard error formula, if we will discuss, the error will be b minus a into h square by 12 maximum of f double dash x. H is the width of the interval, right? And in case of Simpson's rule, the error formula is b minus a whole into h to the power 4 by 180 into maximum of f 4x, that is fourth derivative of f of x. So in case of Simpson's rule, as we studied, it gives exact value for 3 degree polynomial, so f of 4x will be 0, so error will be 0. And for trapezoidal rule, it gives exact value for polynomial of degree 1, so f double x will be 0, so error will be 0, right guys? Then next evaluate for numerical solution of ordinary differential equation. Okay, so what is meant by differential equation? As we know that generally is of the form of dy by dx. So in solving these differential equations by numerical method, we have to assume dy by dx as f of xy. So for first iteration, our what we will get, f of x0 comma y0, right guys? And for evaluating y1, we will get y0 plus h whole into f of x0 comma y0. Okay guys, so x0 and y0 are the first iteration, first initial values, and then y1 is the first iteration. Similarly y2 will be the second, and so on. So if we write the standard formula for Euler forward method and Euler backward method, that will be as shown: yn plus 1 equal to yn plus h f of xn comma yn. Similarly for Euler backward method, yn plus 1 equal to yn plus h f of xn plus 1 comma yn plus 1. Here it will be occur in two steps. Like first you will have to evaluate y1, and xn plus 1 will be and x1 will be what, x0 plus h. I will write it here. X1 will be x0 plus h is the subinterval width, right? So that we have to put it here. Like after evaluating x1 y1, again we will have to evaluate y1, so we can put it as y1 dash. So that will be way more convenient while solving for Euler backward method. Okay, if the y1 is asked, then that will be y1 y0 as per the standard formula into h f of x1 comma y1 dash. Okay, so that will be more convenient while solving, and y1 dash will be evaluated from this formula, that is like the Euler forward method. Okay guys, then let's come to modified Euler method. Here modified Euler method is also known as Kutta second order method. Okay guys, this method is also known as Kutta second order method. Okay, so as for this method, what will evaluate? Y1, that is our first iteration, as y0 plus k, and k is k1 plus k2 by 2. K1 is h into f of x0, comma y0. Similarly, k2 will be h into f of x0 plus h, comma y0 plus k1. And k1 will be evaluated from this. That is initial value f of x0, comma y0. And k2 will be evaluated from using k1, that is f of x0 plus h. As I said, x1 is x0 plus h, so y0 plus k1. And after evaluating k and k1, you have to evaluate k, that is half of the sum of the k1 plus k1 and k2. Okay guys, similarly another method is there, that is Kutta fourth order method. Here also first iteration, that is y1 equal to y0 plus k, and k will be evaluated by the formula k1 plus 2k2 plus 2k3 plus k4 by 6. So k1 formula is similarly h into f of x0 comma y0. K2 is h into f of x0 plus h by 2 comma y0 plus k1 by 2. So while solving, give careful attention to this K2, K3 value guys, because that is different from the Kutta second order method. So here K3 will be h into f of x0 plus h by 2, comma y0 plus k2 by 2. Okay. K4 is h f of x0 plus h and y0 plus k3. Means first middle two terms, that is k2 and k3. Here we are using the half of the previous terms. Okay, x0 case we are using x0 plus h by 2, and for y0 plus k1 by 2 we are using for k2. Similarly, y0 plus k2 by 2 we are using for k3. Okay guys, after evaluating k1, k2, k3 and k4, as per this formula, we will evaluate k, that is k1 plus 2k2 plus 2k3 plus k4 by 6. And the first iteration value will be y1 equal to y0 plus k. So make a note of this guys, because this you have to remember, there is no other way for solving this. So that's for today guys.